So far, we have talked about the ideas of a linear regression problem, which is following. Let's say that you have your data and you can create a scatter plot, this, and you have your independent variable x on the x-axis, and y is your independent variable. And let's say that your data looks like this. So the data points. So the idea is you would like to find a line, which is the linear regression line, which has this kind of formula: y equal to beta 0 plus beta 1 times x, to fit into this data. Now there are a lot of choices for this line. You can have a line that looks like this, or you can have a line that looks like that, or like that. Just by looking at this, you see that obviously the line that I draw first compared to the green and the red lines are the better ones. So why is that? So the least square methods is based on this principle. So let's say that you look at one single data point, for example, this data point. This data point has this value y, value x. So let's say that this is the value y, the value x, right? This is some xi. You see that based on this line, right? Then the predictions is right here. This is the predictions, and this is the value of the predictions. Let's call it y hat I. The truth is this. See that the truth, between the truth and the predictions, is off by a little bit here, this amount. And this amount is called residuals, basically the amount of error that you make by using this line to do the predictions on the value xi. So if you do this for all data points, right? This point right here, all the data points, then you can determine the amount of error that is made for each data point if you follow this model, this line I draw here. So the least square methods is going to find the line where you have the least amount of error made, right? So that's why it's called least squares. So basically you would take the truth, which is yi, minus the predictions that I had, right? Square them, and then you sum them up over. And this expression is set to equal to q. Right? Now, this predictions here, right? This predictions is actually the value of xi on this line, right? So let's call this line. Let's call this line here. We give it the equations: y equal to b0 plus b1. So we can further this expression, write it down as yi. Now y hat I is actually, if you plot the value xi in here, right, it's going to become b0 plus b1 xi squared. So this is basically the total amount of squared error that this line is going to make if you use it to make predictions on the data. So the least square method is going to find the line which is determined by the two quantities b0 and b1, right? One is the intercept, is the slope, that minimize this amount of error. Now we won't go into the details how it's done, but I can show you the formula can be used to compute these two values b1 and b0, where the least amount of error is made. So the formula for b1 is rather complicated, so there are a few formulas here, but I will just write down the most simple one. The formula for b1 is first you have summations over all the data points from 1 to n, and you have the term xi. So we have seen this term when we talk about correlations analysis, and take that, subtracting the following. You have the summations of the xi, sum of all the xi, multiply with summations of all the yi, right? And you divide this quantity by n. So that would be the numerator. For denominator, we have summations of the xi squared, from 1 to n. It's summations of xi, and you square the summations. So notice that there's a difference here. This is the square of each term, and you add them up. Here you add all the terms up, and you square them. So there's quite a difference right by n. So this is the equations for b1. And for b0, it's a lot simpler. b0, you simply take y bar, which is the average of all the value y, minus b1, the one that we just computed using this formula, times x bar, which is the average of the x values. Okay, so let's demonstrate this in our example. So in example 4, we're going to follow through with the examples of predicting the annual sales using the number of profile customers. You will have 4 columns in this table, right? So the first column is x, which is the independent variable, which is the number of profile customers. And then you have y, which is the annual sales. Then you have that term for x squared, so basically the square of all the x, and you have the term x times y. Right? So this data set will have 14 data points, so I'm just going to write a few data points here. So for example, the first one, the first store has 3.7 million customers, and the sales 5.7 million. So x squared, you just take x and square it, give you 13.69. And the next term is x times y, so it should be 3.7 times 5.7. That's give you 21.09. And let's do another row. The next observations, you have 3.6 for the number of customers, and 5.9 for the sales. So x squared should give you 12.96. X times y, 3.6 times 5.9, that's 21.24. Right? So you would do that for all the data points in the data set. So let's look at the last data point. So the last data point have 3 millions for number of customers, 4.1 for the sale, and x squared is 9, and x times y is going to be 12.3. Okay? So that will be the whole data. Now to that, we're going to sum up all the values in each column. So the first column should give you the sum of all the xi, and that should be equal to 52.9. So you add all this value up, it's 52.9. Second column sum of all the yi, sum all the entries in these columns. Give you hints. And we have the third column, sum of all the xi squared. Sum of all this entry here give you 215, 1. And last columns, which is the sum of x times y, and that will give you, which is the sum of all this entry here, give you 32.85. Now we are ready to compute the slope and the intercept of these simple linear regression problems. For B1, right, so we take, let's write that formula, sum of xi yi minus sum of xi sum yi, sorry, divided by n. So n will be the number of total observations, right? So we should have 40 of them. And divided by sum of xi squared, which is the denominator, minus sum of xi, and you square it, and you divide by n. So let's plug in the number. Sum of xi yi should be 382.85, and we have sum of times sum of y, which is 52.9. 92.8 is 14. That's numerator. Denominator, sum of xi squared, which is this one here, got 215.41 minus sum of xi, which is 52.9 squared, and divide by n, which is 40. So this calculations will give you B1 equal to 2.074. After that, we are ready to calculate B0, which is equal to y bar minus B1 x bar. So y bar can be calculated by taking the sum of the y, right, which is 92.8 divided by 14 minus B1, which is 2.074, the one we just calculated, times x bar, which is 52.9 divided by 14. And that should give us minus 1.2. So the formula for the best fit line, the simple linear regression line, is going to be y is 1.208 plus 2.074 times x. So this is the equations of the best fit line. How do you interpret these equations? For the intercept, right? So the intercept with 0 is minus 1.208. That's simply the values of y when x equal to 0, right? So you can plug x equal to 0 in here. That will give you that's simply value of y is equal to 0. Now, in the context of these problems, this one doesn't have much meaning because obviously you probably shouldn't open a store where it has no profile customer, right? So, but if you do, then you'll be at loss. So you'll be losing 1.2 million if you do that. So this problem, this interpretation is not very helpful. What about the slope, right? The slope is B1 equal to 2.074. Now this one has some meaning. The meaning of this one is Let's say that if you take x, right, and you increase it by 1, right? So in this case, let's say we have a store where it has 1 million more customers. Then what happened to y is that, so x increased by 1, that means that we have x plus 1, right? Then y would be what? For that case, we have minus 1.208 plus 2.074 times x plus 1. Then if you multiply this one out, you have 2.074 times x plus 2.074, right? This is our original y, but then we have this extra term plus 2.074, which is this slope. So this one simply means that if you have a store with 1 more million in customers, then the amount of sale increase will increase by 2.074 million. So that's the interpretations. Now, if you have a new store, let's say that you're a new department store and you have the number of customers, you know that it has 4 million, right? Then how do you make the predictions? All you have to do is plug x equal to 4 into this equation, right? So y would be equal to minus 1.208 plus 2.074 times 4. And this comes down to 7.08, or predictions of 7 million of annual sales for a store with 4 million profile customers.